All right, today we're jumping into a fantastic scientific detective story. Our target? The very first piece of the atom ever found, the electron. Seriously, this is a tale of invisible forces, super brilliant minds, and a single discovery that literally changed how we see reality itself.
You know, for centuries, electricity was basically a ghost. We saw it in lightning, right? We've all felt it in a static shock, but nobody knew what it actually was. So the big question is, how did scientists in the 19th century finally pin down this invisible force and get it to spill its secrets? Well, that's the case we're about to crack.
So the first big problem, the first major hurdle, was just figuring out how to study electricity by itself. Imagine trying to study the wind, but you can't separate it from the rustling leaves or the bending trees. It's kind of like that.
Just think about it for a second. When electricity is zipping through a copper wire, how can you tell where the copper stops and the electricity starts? You can't. They're all mixed up together. So scientists realized, hey, the only way we're going to figure this out is if we can get the electricity all by itself, away from the stuff it's flowing through. And there's really only one place to do that, in a vacuum.
But, of course, studying anything in a vacuum is way easier said than done. It's a huge challenge. You need some serious tech. So it was going to take a pretty big breakthrough to build the perfect little trap, a containment cell for this mystery force.
And that breakthrough, it came in 1858, thanks to an inventor named Johann Geissler. What he did was create this incredible new air pump. It was so powerful it could suck almost every last bit of air out of a sealed glass tube. And just like that, bam! Physicists had the key they'd been looking for. Now they could make a near vacuum and build this brand new experimental tool, the Crookes tube.
Okay, so let's break down this trap they built. The design was actually pretty simple and elegant. You start with a sealed glass tube. At one end, you've got a negative wire. That's the cathode. And at the other, a positive plate, the anode. But the real secret sauce, the thing that made it all possible, was using that new pump to get almost all the air out. And that created this perfect, isolated little stage to finally see what electricity does when it has absolutely nowhere to hide.
So, the stage is set. The trap is laid. Scientists flip the switch, run a current through the tube, and right away, they get their first big clue. A strange glowing beam appeared, shooting from the negative cathode straight to the positive anode. Now, this wasn't just some random spark like you'd see in the air. No, this was a focused, kind of eerie beam of light. They ended up calling it a cathode ray, and they figured it had to be caused by something physically moving through the tube and heating up the few molecules of gas that were still floating around in there.
And this discovery, it just kicked off this massive debate in the scientific community. What was this beam? Was it some kind of light, maybe like an X-ray? Was it just pure energy flowing through the empty space? Or, and this was the big one, was it made of actual tiny physical things, little particles? The investigation was definitely on.
So right away, scientists started poking and prodding this thing. They found that if you brought a magnet close to the tube, the beam would actually bend. And if you put electrically charged plates on either side, it would bend again. Well, that told them something huge. Whatever was making this ray wasn't just flying in a straight line. It was reacting to magnets and electricity. It had to have an electric charge. This was a massive, massive clue.
And this is where our lead detective enters the scene, a physicist named J.J. Thomson. He came up with a series of really brilliant experiments designed to finally, once and for all, crack this case wide open.
So in 1897, Thomson decided, you know what, just looking at this thing isn't enough. He was going to straight up interrogate the cathode ray. His plan was to measure everything he possibly could about it. Its speed, its charge, its mass. He was going to force this thing to tell him exactly what it was.
And what he found was absolutely stunning. First off, he measured its speed. It was moving at about 1/10 the speed of light. Now, that sounds fast, but it's way too slow for any kind of light or radiation, so boom, that theory was out. Next, he confirmed that the beam bent toward a positive plate. That's a dead giveaway. It had to have a negative charge. But the final discovery, that was the real bombshell. He managed to measure the ratio of the particle's mass to its charge, and what he found was that this ratio was always the same. It didn't matter what metal the cathode was made of or what tiny bit of gas was left in the tube. The particles were always identical. And that could only mean one thing. These particles weren't little bits of copper or iron. They had to be a fundamental part of all matter. This led Thomson to this absolutely revolutionary conclusion. The rays had to be made of particles. No doubt about it. And since these particles were negatively charged, well, they couldn't be atoms, because everyone knew atoms were neutral. He had found something completely new, a piece inside the atom.
So, Thomson had basically identified the culprit, but there was still one piece of the puzzle missing. See, he could only figure out the ratio of its mass to its charge, not the actual mass itself. So the big question hanging in the air was, just how tiny was this new particle?
You know, science is often like a relay race. Thomson ran a brilliant first leg, but now it was time to pass the baton. And 12 years later, in 1909, an American physicist named Robert Millikan grabbed it. Using this incredibly clever experiment with oil drops, he managed to do something amazing. He measured the exact charge of one single electron. And with that number, scientists could finally plug it back into Thomson's ratio and calculate the final missing piece, the actual mass of this particle.
And the answer was just mind-boggling. They calculated that the mass of this new particle was about 1/1800th the mass of a hydrogen atom, which was the lightest thing anyone knew of. Think about that. It wasn't just a little bit smaller than an atom, it was ridiculously, almost unimaginably tiny.
So the verdict was in. For literally 2,000 years, people thought the atom was it, the smallest, indivisible thing in the universe. And in one glowing glass tube, J.J. Thomson proved all of that wrong. A fundamental particle, something smaller than the atom, had officially been discovered.
So you gotta wonder, right? Why the electron? Why was it the very first piece of the atom we found? And why did it happen right then? Well, the answer really comes down to its own special properties, and, just as importantly, the technology that was available.
Really, the electron was found first for a pretty simple reason. It's the easiest part of the atom to get to. It kind of hangs out on the outside, it's not too hard to knock it loose, and crucially, it's the particle that actually is electricity, the very thing scientists were already trying to figure out. It was basically the low-hanging fruit of subatomic physics.
And this discovery, there's just no way it could have happened any earlier in history. The ancient Romans, scholars in the Middle Ages, they had no shot. You absolutely needed two key technologies to be in place first. You needed to be able to make and control electricity, and you needed to be able to create a near-perfect vacuum. The Crookes tube was simply the right tool that showed up at exactly the right time, and once it did, finding the electron was almost guaranteed to happen.
And so, the case was closed. The discovery of the electron was that first big crack in this 2,000-year-old idea that atoms couldn't be broken down. It proved there was a whole new world, a much more complex world hiding inside matter. But you know how it is in science. Every answer just leads to a bigger question. Now that scientists knew for sure that atoms had parts, the next great mystery was obvious. What else was hiding in there?